In no nation on Earth are the effects of climate change more severely felt than in the Maldives, an island nation off the coast of India, home to about 350,000 people, which is literally in danger of sinking into the ocean should sea levels continue to rise. To give you an idea of how scary this is, here's a picture of the nation's capital, Male. The city is home to 100,000 people and twice as dense as New York City. Yet, the city is only about 2.4 meters above sea level at its highest point. To put that in perspective, here's a picture of Santa Monica Beach. 2.4 meters would be right around here. If a large wave or tsunami reaches the Maldives, the nation would certainly be ruined. In fact, in the tsunami of 2004, the nation had to spend money equivalent to 3/4 of its annual GDP to repair the damage. But who needs a tsunami? 80% of the Maldives' land area is below a meter in elevation. If we look at the EPA's prediction for sea level change, we'll see that 80% of land could be underwater by as soon as 2070. As you go through this chapter, please let the Maldives remind you that what you're about to learn are not just shocking figures on a chart designed to scare you, but that they have real and profound real-world effects, such as the existence of this country.
Climate changes are discussed every day in newspapers, in politics, and in S101. What is climate change? Well, climate is the long-term atmospheric conditions for a specific area. Global climate change affects billions of people throughout the world, and even in S101. The most important aspect of global climate change is global warming. As you can see in figure 18.1, the sun and the atmosphere warms the earth. At the same time, greenhouse gases such as carbon dioxide, nitrous oxide, and methane warms the atmosphere. Through the greenhouse effect, the earth first absorbs surface radiation, then the surface re-emits infrared energy into space. Due to greenhouse gases, some of the energy travels back toward the earth's atmosphere, thus increasing the earth's surface temperature. The greenhouse effect is natural, but due to human activities such as fossil fuel use, human development, and industry, concentration of these gases dramatically increase, therefore enhancing the greenhouse effect.
CO2 is not exactly that strong of a greenhouse gas, but there's a lot of it. Imagine our quizzes. One quiz doesn't do that much, but many quizzes can make a big difference. Water vapor is also abundant, but it could give us benefits by making it cloudier and reflecting the solar radiation to cool the surface. These are like note cards. They help us pad the damage, but it can only do so much. Aerosols are these small particles that could absorb the solar radiation and warm the surface, as well as particles that could reflect the solar radiation and cool the surface. You could use radiative forcing to measure the impact of these factors such as greenhouse gases and aerosols on the warming and cooling of the surface. Here is a picture of the graph of radiative forcing. As you could see, negative forcing causes surface cooling, while positive forcing causes surface warming.
Interactions between the ocean and atmosphere that influence climate is called the El Niño Southern Oscillation, or ENSO for short. El Niño are conditions that are triggered when air pressure increases in the western Pacific and decreases in the eastern Pacific. So for El Niño's case, let's say we have a ball of Febreze, and you're in the western or left part of the room. You spray Febreze. It's pretty strong in the west, but as it gradually flows on, it will decrease in the east. And the opposite of El Niño is La Niña, which are events that are when cold surface waters extend far west in the equatorial Pacific and weather patterns are affected in opposite ways. Thermohaline circulation is a worldwide current system in which warm, fresher water moves along the surface, while cold, saltier water moves beneath. And the cold, saltier water moves beneath because it is more dense. This process is repeated all over the world and allows heat to flow to places that won't receive it otherwise, like Europe.
The Milankovitch cycles is a series of patterns in which Earth's orbit changes as it goes around the Sun over thousands of years. Earth's orbit wobbles around the Sun, and also its axial tilt varies over time, which creates both different angles and different distances around the Sun, and thus making Earth's climate vary according to these changes.